In this video, you will learn how to use LaTeX equation environments which are available in amsmath package. These environments are used to write mathematical equations in LaTeX, which is a typesetting software of choice for researchers, PhD students, and authors who write books, in particular mathematical or scientific books, in which they have to write the math expressions or equations. So let's get started after a short break. Hello and welcome to my channel. My name is Tahir, and if this is your first time, please hit the subscribe button and also the notification bell to get notified whenever I post a new video on this channel every Tuesday and Friday. LaTeX is not just free, it is the best typesetting software for scientists, researchers who are writing research papers, scientific books or mathematical books. The major advantage of LaTeX is that it can handle mathematical expressions in a fantastic way. The fonts are unmatchable and best for this job. Because there are about 8 or 9 environments which I will be explaining to you, this video might be a little bit longer than my normal videos. So please grab a cup of coffee or tea and watch this video till end and master the art of writing mathematical equations in LaTeX. You will learn how to format the equations, how to number them, because sometimes you want to number them in sets, sometimes you want to number them individually, how to align them, and how to format them in general. And now I will jump on my computer and I will explain to you all these LaTeX equation environments. LaTeX is a typesetting software, and when you are writing mathematical equations, you have to use one of these environments. And any block of code which starts with \begin and ends at \end is called an environment. So whenever you want to use any of these environments, you have to start like this. So here I am using equation environment, and then I can write my equation within these two lines in my text file. All these environments are defined inside amsmath package, and you have to include this line, use package amsmath, in the preamble part of your text file, in the beginning of your text file after the document class. Now whenever you want to decide which environment you should use to write your equation, there are 4 important factors you need to consider. The first is how the alignment works in that particular environment. The second is how many alignment places are available. And the third factor is what type of numbering we want, whether we want numbering at each line or we want numbering at a set of lines. The fourth important factor is whether or not that particular environment can be nested within another environment, because sometimes we need to nest one environment inside the other environment. And we will see with these examples how all this selection is made. Now here is the starting example. Equation is the most common environment used, but this environment is best suited for only one equation. When you have only one equation, you should use this environment. And you will see in a minute why. Now this is the sample code. I will be showing you the LaTeX code on the left hand side and the result in the PDF on the right hand side. So when I use this code, I will get this result in my PDF. But all this code has been tested, and at the end I will show you how you can get this file in which all this code is available, and you can test on your system as well. Because in my opinion, it is easier for me to give you the explanation when I show the code side by side instead of compiling everything again and again. So this is a situation in which we are simplifying some equation. So this is an equation, this is the first step of the equation, then we simplify it to the next step, and then we further simplify it to another step, and then we finally get 2 more steps, and then we get the result. So if I use the equation environment, as you can see that I am trying to put this double backslash, which in LaTeX means go to next line. So it means that I want at this stage to go to the next line. So this next thing I want on the next line. But this environment has a problem. It ignores all these line insertion commands, and it tries to put all those on a single line. Here what I want to do is to go to the next step at each line so that I can show the simplification in my, let's say, any lecture or in my presentation or in anything. And now let us see what we can do about this. So let's get introduced to second environment, EQ and array. So this ampersand is called the alignment operator. Now this solves one of our problems, because in the previous equation environment, that environment was ignoring this double backslash and it was not going to the next line. But in EQ and array environment, as you can see that whenever I put double backslash, it goes to the next line, and it also in the output, as you can see, that it goes to the next line and then next line and so on. So now I can show the simplification of this problem at each step by showing on the next line. So that problem is solved, but still we have two following issues, and I will talk about this how to use ampersand in the next slide. But here there are two more issues which we want to solve. Number one, since I am simplifying a problem on my presentation or on my lecture or anywhere, I don't want these numbers to increase at each step because I am solving the same problem. So this is one problem with EQ and array environment, that it is also increasing the equation number. And the second thing is, I want this equal sign to appear underneath this equal sign at each step. You might be okay with this type of formatting, and if you are okay, then you don't have this problem. But I also want to control this alignment, and we can handle this alignment issue by using this alignment operator, which is ampersand. And now we will discuss how to do the alignments of all these equations. Okay, now let's see how we can use these alignment operators. And one thing to note in this example is that in this example we have nothing on the left hand side of equal sign. So there is nothing here. So the only numbers or symbols we have are on the right hand side. So in the next slide I will show you the example where we have symbols on both sides of the equation. So we are using the EQ and array environment, and in the first part what I am doing is I am doing the first AND operator before the equal sign and the second AND operator after the equal sign at each of these lines. So whenever I enter into the new line, I am using both operators on both sides of the equal sign. So what I am telling here is that align strictly at equal sign. So now all my equations, this one and all these, they are aligned at the equal signs. As you can see that they are perfectly aligned here. Now in the next example at the bottom, what I am doing is I am putting one alignment operator before the equal sign, and I am not using the second operator. So in this case what LaTeX does is LaTeX optimizes the position of the equal sign, because all these equations have varying lengths. So LaTeX will try to optimize the best output for this situation when I don't have any number on the left hand side. When I have number on the left hand side, the situation might be different, and this is what you will be doing with this AND operators. If your equations are of different lengths, some equations have numbers on both sides, some equations have numbers only on one side, then you have to play with this and see what is the output which you want. And now you will get some more understanding when we will do some other example. So let's see the next situation. Now here is an example where we have numbers on both sides of the equal sign. And few things to note here is that on the left hand side we have numbers with 3 digits, 4 digits and 5 digits in order to see how the alignment is working. And in the first part what I am doing here is I am using both of these alignment operators at both sides of the equal sign. So I am strictly aligning on both sides of the equal sign, and this is the result. As you can see that this alignment is perfectly fine before the equal sign, and also after the equal sign the alignment is perfectly fine. Now in the second case I am using only one ampersand operator before this equal sign. So the result, as you can see, that before the equal sign the numbers are aligned, but after the equal sign and equal sign itself, they are optimized by the software. And basically, as you can see, that these are just kind of center aligned. So software tries to optimize the result on this part of the equation, because it thinks that we are only interested in aligning the equation here. So in some situation you might want this result. So there could be a situation. In most cases we use this kind of operators, and now I will be using two operators. So here I am mentioning two situations in which I am using both operators. So in the first example I am using one operator at the beginning of my equation and one before the equal sign in all of these lines. As you can see, in all of these lines I am using these operators like this, and the result is that equal signs are aligned perfectly fine here, but the left part is being optimized, because when I put the ampersand operator here, it's impossible to align all these ones and all these equal signs. It is impossible because the width is different at in each of the equation. So therefore the software aligns at the equal sign, because equal sign is considered as a natural alignment location, and then it optimizes the left hand side. Now what happens if I use one operator before the equal sign and one operator at the end of the right hand side? So in this case, as you can see that the equations are aligned just before the equal sign, but the right hand side is being optimized by the software. Software tries to center align all these three equations on the right hand side. So you have to figure out what suits best for you. For example, you might want to put one here and one here and see what is the result. Now let's come back to our initial issue. This was our equation and we wanted to split this on various lines. So we used eqn array environment with the ampersand, and we got the alignment right, but we got various equation numbers. So how to remove these equation number and get only one equation number? So in order to do that, we have to use an environment which is called split environment, and the only two lines we have to add inside the equation environment is this one, begin split and end is split. So this environment can be nested inside the equation environment. The rest is exactly the same. So the only thing is that now environment will not ignore this double backslash, and it will go to the next line just like the eqn array environment, and also it will not put the line number at each line, unlike the eqn array environment. So this is the way you can achieve this kind of functionality by putting split environment inside the equation environment. Now one problem is solved, but still I want to align this equal at each line. So let's see how we can solve that part of the problem. Now to solve this equal alignment problem, we have to use again the alignment operator, and the good thing is that split environment also provides us this alignment operator, so which we can use before these equal sign to get this alignment at the equal sign location. So this is how finally we achieved what we wanted. So your situation could be different, but I am just using one example to show you how to handle these kind of situations by manipulating the alignment operators and by nesting one environment inside the other environment, or other techniques you are learning in this video. Now another useful environment is called Multiline environment, and this environment is used when you have long equations. So this equation is very long and I want to split at this point. I want to split this equation to the next line, but I don't want to start from the very beginning. I want to start somewhere in the middle in order to show that it is still the same equation. So this looks better. It shows a continuity and it only has one number. So when you have longer equation, you just use multiline environment and wherever you want to split the equation, you just put this double backslash, and at that particular location whatever is written after that will be printed in the next line. So very useful environment in some situations. Now the next environment is align environment. This is very easy to use environment and very intuitive, and this environment can be used in these type of situations. Let's say I have these three equations and I want to number them separately, but I can use the align environment to control the alignment. For example, in the first part of this slide, I am using this alignment operator just before the equal sign to align these three equations at the equal sign. So as you can see that equations are aligned here. In the second part of this slide, I am using the align operator at the start of these equations. As you can see that this is the align operator in the beginning and the equations are aligned in the beginning. You can note here that this 3 is aligned with the x, not x's are aligned, because I am putting the operator at the very beginning. Now the third part, I just wanted to show you that you cannot put the conflicting instruction, because in that case the software will try to optimize the alignment. Here what I am doing is I am asking the software to align at the beginning, which is perfectly fine. Anything can be aligned in the beginning. But then I am also putting another condition that align this before the equal sign, which is not possible because all these equations, they have various widths. This is longer equation and these two are relatively smaller. So therefore, if the equations are aligned here, so it's not possible to align them at the equal sign, because even if it allows the alignment like this, the software have to change this distance, or you can say adjust this distance. So then software tries to optimize the alignment, and in most cases you will see that it will right justify. It will just align the right side of the equations. So now this is another situation in which what I want to, for example, explain to someone in a more clear way, and I want to align all the x with the coefficient or in whatever manner. Then I want to align all the middle terms, and then I want to align all the z's and also the equal sign at the end. So in this type of situation, I have to carefully put these alignment operators. So if I want to align all x, so as you can see that I am putting this before x. The alignment operator is before x. Now this second operator acts as a separator. So basically I am telling the software that I need a separation between this column and the next column. And in the next column, I am aligning this minus sign with the plus sign like this. And in the third column, I also want to align at the signs, not at the z, but at the sign before the plus and before the minus. So now here these signs are aligned. Then this is another separator. This ampersand is acting as a separator. And then I want to align the equal signs. So therefore equal signs are aligned. Now if I want to add another separation after this equal sign as shown in the bottom part of this slide, so then I need to add another ampersand after this equal sign, as you can see here. So this ampersand is adding this separation. So basically one ampersand is for the alignment and the other is for the separation. And then of course still software has to optimize these distances, the distance between these two and all these. So these are the 4 separations, and 1, this is 2, this is 3, and this is 4. And if you want, for example, more separation between these two in any situation, so you can add another ampersand here. Just if you add another one here, so you can increase this distance between these two. Then again the software will try to optimize that how can it keep this distance double the distance between these and these and this, because you are putting 2 ampersand here and 1 here. So this will be relatively double to all other separators if you put this second one here, and then software will calculate this and put the separation. So if you want ultimate kind of alignment where you are aligning each individual column, then you have to use more ampersand operators, and this align environment allows us to do this. So there is another environment which is called aligned. So what is the difference between these two? So the main difference is that this aligned environment cannot be nested inside any other equation environment, while you can nest this aligned environment inside other environments. And this is very important because let's assume that I want to name all these three equations or any other equations as a single equation, and we know that for a single equation is the best environment. But at the same time I want to align these in the manner in which I have aligned here using the align operator. So what I can do is I can simply change this align to aligned and then nest this environment inside the equation environment by putting these two lines at the top and bottom, begin equation and end equation. So this is the only difference between these two set of codes, and the result is this, that now I have only one equation instead of three because I am using the equation environment. And another difference is that when this align environment is used independently, then it covers all the width of the page. But when we use this aligned environment, the whole width of the paper is not covered. And the benefit is that we can put something else here. Let's say I want to put some curly brackets here around these equations. So I cannot do in this aligned environment because there is no space. Technically, there is no space available in this area. But in this situation, I can put these brackets, and you might have seen these kind of brackets in many mathematical books where you want to put a curly bracket. So this can be done by using the aligned environment. And this is how we can put these curly brackets if we want. Outside this aligned environment, this is our aligned environment, and outside this we put this backslash left and backslash this curly bracket. And then after this aligned we put backslash right and backslash this bracket. So the effect will be that there are two brackets before and after our equation. And if you don't want, for example, the first one, you can simply put a dot here. This is a dot, and you remove this backslash and this curly bracket, and you will get this kind of result. For example, you want to write something on the right side of the parenthesis, which normally we have to do. So to do that, you have to put this backslash text, and then inside these curly brackets whatever text you want to write down. And we are using backslash text because we are writing in the math mode, and if you don't use that, then the font of the text will be different because you will be writing in math mode. And you also have to take care of how the spaces work in math mode. You have to put a tilde sign and so on. So keep this in mind. Now another environment which is useful sometimes is called gather environment, and this environment is used when no alignment is required, because when alignment is required we use align environment or aligned environment. Aligned where nesting is also required, and align when only alignment is required. Similarly, when alignment is not required we use gather, and there is also a gathered version with the ed, and gathered can be used in nesting environment while gather cannot be used in nesting environment. So what this gather does is it simply centers the equation separately within the available text width. So for example, this is your text width from here to let's say here. So it will try to center your equations independent of each other, and you can also nest split environment inside the gathered environment. This is possible. For example, if any of your equation is lengthy and it has 2 or 3 steps or 2 or 3 lines, so you can use split environment inside the gather environment. Now the last thing is about the program which I use to explain these environments. So this is the LaTeX program which I have tested. As you can see that the PDF is on the right hand side. So all the code which I mentioned in this video has been tested, and you don't really need to get this file. You can simply type any equation, not necessarily the same equation, and you can practice it. But even then, if you want this file, there is a link in the description. Just join my email list, and when you get the welcome email, reply to that with a message that you want this text file. Only then I will be aware that you want this file, and I will attach this file and send it to your email. And I hope that now you understand how LaTeX equation environments work, and you can use them to write mathematical equations, to format them, to align them, and to number them appropriately. So I hope you like this video. If so, please give it a thumbs up and subscribe to my channel. Thanks for watching. See you next time.